There are several ways for us to visualize what happens to numbers when we multiply them with other numbers. We can use the tape diagram, the area method, the grid method, and the standard algorithm. In this video, we will discuss multiplying numbers using the tape diagram method. Multiplying numbers using the tape diagram is great for math students who are still beginners, like those in kindergarten up to the third grade. The other methods are a bit more advanced, and we will discuss them later on. The tape diagram also shows us an interesting property of multiplication, which is called the commutative property. To use the tape diagram, imagine you have pieces of tape on a number line. Now, the length of the tape strips are measured by how many numbers they take up on our number line. So if I want to have a tape that is 5 numbers long, I can draw a strip from 0 to 5, just like that. So this strip is 5 numbers long. Starts from 0, and you can see it's 1, 2, 3, 4, and 5. Now look closely to see what happens when we do multiplication of numbers, as can be seen in this tape diagram. If I wanted to multiply 5 by 4, meaning I want to repeat the strip, which is 5 numbers long, 4 times, then we just draw our strip 4 times. So we're going to draw 4 strips that are 5 numbers long. This is the first strip. This is the second strip. You can see it's also 5 numbers long. That's 1, 2, 3, 4, 5. This is the third strip. Also 5 numbers long. That's 1, 2, 3, 4, 4, 5. That's our third strip. And we have our fourth strip. Also 5 numbers long. 1, 2, 3, 4, 5. So here's a strip that is 5 numbers long multiplied 4 times. So this can also be written as a strip that is 5 numbers long multiplied by 4, meaning there are 4 of these strips, and that is equal to 20. Now you can see that this also shows us that 5 multiplied by 4 is actually 5 plus 5 plus 5 plus 5, which is equal to 20. So 5 times 4 is the same as 5 plus 5 plus 5 plus 5, which is equal to 20. Interestingly, 4 multiplied 5 times is also 20. Let's see that drawn on the tape diagram. So we have strips that are 4 numbers long. Okay, this is our first strip. It's one strip. You can see that it's 4 numbers long. 1, 2, 3, 4. Let's draw another one. 1, 2, 3, 4 is our second strip. 1, 2, 3, 4 is our third strip. 1, 2, 3, 4 is our fourth strip. And the last, 1, 2, 3, 4 is our fifth strip. This also means that 4 plus 4 plus 4 plus 4 plus 4 is equal to 20. As you can see here in the strip, that's 4 plus 4 plus 4 plus 4 plus 4. So you can see that 5 times 4 is equal to 20 is just the same as 4 times 5 is equal to 20. So even if we switch the first and second numbers in our multiplication operation, it just arrives at the same answer. Now this characteristic of multiplication, where you can switch the number to be multiplied and the number to multiply by and still arrive at the same answer, is called the commutative property of multiplication. Let's try a bigger number this time, say 8 times 4. So what that means is we have a strip which is 8 numbers long, and we are going to multiply it or repeat it 4 times. Let's say we have 8 times 4, and we're going to find out what the answer is. So we have a strip that is 8 numbers long. It's 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's one strip. 1, 2, 3, 4, 5, 6, 7, 8. It's another strip. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8. That's our third strip. And then the last is 1, 2, 3, 4, 5, 6, 7, 8. So these are strips that are 8 numbers long, and we have 4 of them. That's strips that are 8 numbers long multiplied by 4, or 8 plus 8 plus 8 plus 8. And we can see here that the answer is 32. So 8 times 4 is 32. Now again, it's very interesting to note that 8 times 4 is just the same as 4 times 8. And it's supposed to give us the same answer. So let's try to draw strips that are 4 numbers long. Okay, that's 1, 2, 3, 4. That's our first strip. Our second strip is 1, 2, 3, 4. 1, 2, 3, 4. It's our third strip. 1, 2, 3, 4. Our fourth strip, 1, 2, 3, 4. The fifth strip, 1, 2, 3, 4. That's the sixth strip, 1, 2, 3, 4. That's seventh strip, and 1, 2, 3, 4. That's the eighth strip. And you can see that we arrive at the same answer, which is 32. Now, by the way, 4 times 8 is also just the same thing as 4 added to itself 8 times. So that's 4 plus 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 4. As can be seen here in this tape. That's 4 plus 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 4. So the great thing about the tape diagram is that it helps us see what is happening whenever we multiply numbers, and it also shows us the commutative property of multiplication. Let's try a bigger number, and this time without using a number line anymore. Say, let's multiply 12 and 11. So 12 times 11 is actually just like adding 12 to itself 11 times, which is just like drawing strips that are 12 numbers long 11 times. So if we add all of these 12s, which are added to itself 11 times, we are going to get 132. And let's try to solve that using standard algorithm. So that's 11 times. So if we add all these 2's together, we're going to get 22, but we carry over 2 over here. And then we add all these 1's. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus 2. So 11 plus 2 is 13, and we get 132. So the answer to 12 times 11 is 132. Of course, our commutative property tells us that switching it to 11 times 12 should also give us the same answer. So if we use the standard algorithm to add 11 to itself 12 times, so if we add all these, we get 12, and we carry 1, and then we add all these together, that's 12 plus 1. 12 plus 1 is 13, which is just the same. So 12 times 11 and 11 times 12 just give the same answer.